Welcome to the second asynchronous session. We are going to do this asynchronous session on factoring, zeros, and end behavior, which covers lessons 7, 8, and 9 of Unit 2. The objective for this lesson is that students will be able to factor polynomials, find zeros, and determine the end behavior of a polynomial. So by the end of this, you should be able to do all of those things. So the first thing that we're going to look at is these are some of the different types of methods that you can use to factor polynomials. Depending upon the type of polynomial will depend upon which ones you are able to use. And then for some polynomials, there's multiple ones that you can use, so it will just be up to you to decide which one fits you best. So we're going to go through each one of these one by one as we go through the next few slides. So the first one is the greatest common factor. So with the greatest common factor, in order to factor it, the first thing you want to do is you want to look at all the terms and you want to figure out what is the greatest common factor between them all. So since we have a 5 out here in front of our largest degree term, I'm going to see if 5 goes into 15. So if we take 15 divided by 5, we get 3, so it does. And then 5 does go into 100, also we get 25. So the way I'm going to factor this is I'm going to pull the 5 out in front because that's my greatest common factor, also known as a GCF. And then I'm going to take that 5 out of each of these terms and rewrite those in the parentheses. So we're going to have x cubed for the first term plus 15 divided by 5 is 3. So we're going to have a 3x plus 100 divided by 5 gives us a 20. Now if you don't know how to do that division in your head, go ahead and use a calculator in order to do it. So with greatest common factor, I just take out my greatest common factor, and then if I can factor it more, I factor it more. For this one, we can't factor it anymore, so this would just be our final answer of how we would factor this one. So now the next one we're going to move on to is we're going to move on to perfect square trinomials. So if it's a perfect square trinomial, like this one is here, 4x squared minus 12x plus 9, when it's a perfect square trinomial, that means that we're going to end up with the same factor, that we're going to end up finding the factors that go into the first term here and what the last term is. So since it's a perfect square, that means we're going to take the square root. So we're going to take the square root of 4x squared, which when we take the square root of that, we take the square root of each part. So the square root of 4 is 2, and the square root of x squared is, remember, square root and square cancel out, so we're just left with an x. So the square root of 4x squared is 2x. Then we're going to find what the square root is of 9. So the square root of 9 gives us 3. So we end up with the square root of 4x squared is a 2x, and the square root of 9 is 3x. So when we write this out, we should have that we have 4x squared minus 2 times each of those factors that we just got, 2x, and then times 3 plus 9. So when we multiply 2 times 2 times 3, we should end up with the number that we had, which is a 12, which we do end up with that. So that means that we factored this correctly. So now the way that we're going to write this is that we are going to factor this. So we need to take our square root here. So we got our 2x is one of them. So we're going to have a 2x there. And then since we have a minus sign here in the middle and a plus sign here at the end, that means we're going to have a minus in the middle. If this was a plus and a plus, we'd have a plus. If the middle here was a plus and the end here was a minus, then we would have 1 that would be a plus sign. Then we would have not have a perfect square trinomial. Okay? So we're going to have our 2x, and then then we're going to use our other term here, our square root of 9, which is 3. And then since it's a perfect square trinomial, that means we're going to have the same factor again of 2x minus 3. Now if you're not sure if you have this right or not, you can always FOIL it all back out and see if you end up with your original term. So then since we have two of the same, we can go ahead and combine them and write it simpler so that it's just 2x minus 3 quantity squared. And that would be our answer for how we would factor it using perfect square trinomials. So now let's go on to the next one. The next one is a quadratic. So you should have learned how to factor quadratics before. And so the easiest way to figure out what you need to factor it to is if you draw a big X here, and you're going to take your A times your C on the top, and then you're going to put your B on the bottom. So remember that it goes ax squared plus bx plus c. So our A is 2, our C is a plus 3. So here AC, we're going to multiply 2 times 3 gives us a 6. And then on the bottom, we're going to write our B. Now you have to include whichever sign it is in front, plus or minus. So since we have a minus here, that means our B is a minus 7. So now we need to figure out what two numbers multiply to give us a negative 6 and add to a negative 7. So if you know your factors of 6, your factors of 6 would be a 6 and a 1, and then you would have a 2 and a 3. So we want to know what two combinations of those would give us a 7. So if we add 6 and 1, that gives us 7. If we add 2 and 3, that gives us only 5. So that means that we don't want to use the 2 and the 3. We want to use the 6 and the 1. So we're going to have a factor of 6 and we're going to have a factor of 1. Now the other thing we need to take into account is we need to take into account the sign. So our B is negative. That means we need to add up to a negative 7. So we have a 6 and a 1. If we add them together, currently it's a positive 7. So let's say I make the 1 a negative. If I add 6 and negative 1, I get a 5. That's still not what I'm looking for. So if I make the 6 a negative also, when I add negative 6 plus negative 1, that gives me a negative 7. So now, those are my two factors, negative 6 and negative 1. So we're going to have 2x squared minus a 6x minus a 1x plus 3. So we're taking those two factors that we just found, and we're splitting our negative 7x up into a negative 6x and a negative 1x. Now we're going to factor by grouping. So I'm going to group the first two terms together, and I'm going to group the last two terms together. So now I'm going to use my GCF, take out what the GCF is. So we're going to take out a 2x in the first one, because that's my greatest common factor between 2x squared and negative 6x. And then what do I have left? So if I have 2x squared and I take out a 2 and I take out 1x, that means I have just 1x left, minus 6x, I took out 2x. So my x is gone now, and 6 divided by 2 gives me a 3. So now we're going to move on to the second one there. We need to figure out what our greatest GCF is. So we want our x to be positive here, because we want it to match the one here that we had before. So we want a positive x. So we're going to factor out a negative 1. When we factor out a negative 1, that just means we're going to change the sign in front of each of the terms. So then you see we ended up with an x minus 3 and an x minus 3. So we're going to factor out, that's our greatest common factor now, is x minus 3. And then in parentheses next to it, we have left a 2x minus 1, because those are our two terms left here when we factor out the x minus 3. And this would be our answer for how we factored the quadratic. Let's move on to the next one. Difference of squares. So if you remember the difference of squares formula, that was a squared minus b squared equals the quantity a plus b times the quantity a minus b. So what that means is we first need to take our first term and we need to find what its square root is in order to get that value of a. So we need to know what is the square root of 25x squared. So if we take the square root of 25, that gives us 5. The square root of x squared gives us x. Now we need to also find our b. So in order to find b, we need to do the same thing. We're going to take the square root of 16. What is the square root of 16? Well, it's 4. So now we have our a value is 5x, and we have our b value is 4. So now we're just going to plug it into the equation here, and that's going to give us our answer. So we're going to have 5x plus 4, and we're going to have a 5x minus 4. And that is how we factor it for the difference of squares. So now our next one is the factor theorem. So if you remember back to going through the lesson, it tells you about what the factor theorem is. We want to know, is x minus 3 a factor? So in order to find out if x minus 3 is a factor, we can go ahead and we can plug the 3. Since we have a minus sign here, we can just plug the 3 in. So we want to find what f of 3 is. If f of 3 equals 0, that means it's a factor. So I'm going to plug 3 in for everywhere I see an x. So we're going to have 3 cubed minus 3 times 3 squared plus a 4 times 3 minus 12. And then we're just going to go ahead and solve it. If you need to use a calculator, feel free to use a calculator. So 3 cubed, you remember when you type this in a calculator, if you don't have the exponents, that the exponent does not mean 3 times 3. The exponent means we're going to do 3 times 3 times 3. We're going to multiply 3 by itself 3 times, and that's going to give us a 27 minus 3. We're going to do our parentheses here first. 3 squared is a 9 plus a 4 times 3 is 12, and then minus 12 there at the end. So now we still have one more parentheses here to finish up before we can start adding and subtracting. So we're going to have 27 minus 3 times 9 is 27 plus 12 minus 12. So now if we add and subtract, 27 minus 27 gives us a 0, plus 12 minus 12 also gives us a 0. So we end up with 0. So that means that x minus 3 is a factor. So if it says find all factors in any of your problems, well, you know that x minus 3 is a factor. So then you would have to take their equation and get the x minus 3 out, which you haven't learned yet. You'll learn that in Unit 3. So for now, we're not going to actually find all factors. We just are verifying that x minus 3 is a factor by using the factor theorem. Now we have the sums and differences of cubes. So we have a formula here depending upon whether we're doing the sum of cubes or the difference of cubes. So we need to look at our problem that we're doing. So the problem that we're doing is 8x cubed minus 27. So we have a subtraction sign there. So that means that we're doing the difference of cubes. So we're going to use this bottom equation here. So we first need to figure out what our a is, and we need to figure out what our b is. So we need to take the cubed root of each of those. If you don't know your cubed roots, you may want to review the most common ones so that you know what they are fairly quickly. So you should be able to know that the cubed root of 8 is 2. And then if we're taking the cube root of x cubed, remember the cubed root of anything cubed cancels out, so we're just left with x. Then we need to take the cubed root of 27. That should also be a cube root that you know. The cubed root of 27 is 3. So we now have our a, and we have our b. A is 2x, and b is 3. So now we're just going to plug that in into the equation here and get our answer. So we're going to have a minus b times the quantity a squared. Make sure you put parentheses around your a, otherwise it's going to look like you're only squaring your x if you don't have the parentheses there, plus our a value times our b value plus b squared. So the last thing is we're going to actually go ahead and calculate what's inside of our second parentheses. So we have 2x minus 3. And then if we do 2x squared, so we're going to take 2 squared gives us a 4. And then x squared gives us x squared. Plus 2x times 3 gives us a 6x. Plus 3 squared is 9. So that is our factorization of the sum or difference of cubes. So let's go on to the next one. So now we're on to grouping. So we did grouping earlier when we did the quadratics, where we grouped the first two terms together and the last two terms together. In order to do grouping, you have to make sure that your terms are in descending order. So you have to make sure that your biggest degree is in the front, and it goes down from there until your lowest degree. So then we're going to group our first two together, and we're going to group our last two together. So out of our first two here of 2x cubed and 3x squared, our greatest common factor is x squared. So we're going to factor out an x squared. So 2x cubed factoring out an x squared gives us a 2x, minus 3x squared factoring out an x squared gives us a 3. Now we need to figure out what our greatest common factor is between our next two. Well, there's no greatest common factor between 2 and 3, and there's only an x in our 2x. But we have this minus sign. Now we want this to be positive in front. We want our x to be positive. So that means our greatest common factor is actually going to be -1. And it may be -1 sometimes. So we're going to just take out a -1. So we're just going to change the sign of everything. So we're going to end up with 2x minus 3. So now this is good because we have our two parentheses are the same thing, which is what we want. So that's our greatest common factor now that we're going to factor out. So we're going to have our 2x minus 3. And then in our second parentheses, we're going to have what's left over. So we have x squared minus 1. Now we need to check to see if we're actually fully done factoring or not, since we still have a squared here. Is this fully factored? Well, it's not, because we have a difference of squares. So then we have to use our difference of squares. So we're going to keep our first one the same of 2x minus 3. Then we're going to do our difference of squares. So if you remember from the previous slides, how we do our difference of squares is we have the square root of our first term, which would just be x, plus the square root of our second term, so the square root of 1, which is 1, and then times the square root of our first term, which is x, minus the square root of our second term. So this would be our full factorization of our equation. Alright, let's move on to our next one. So the complex conjugate root theorem. If you attain a root of 3 plus 2i as a solution to a polynomial, then you also know that 3 minus 2i is also a root of the polynomial, since the theorem states that complex solutions come in pairs. So this is just a theorem that you need to know so that if you end up with a complex root, you know that you should have the complex conjugate as a root also of your polynomial. So there's no calculations needed to be done here. It's just a theorem that you need to know so that you know that if you get one root that's complex, that you're gonna have the complex conjugate as its pair for a root also. Okay, so go ahead and see if you can factor this polynomial. Choose whichever method you would like to do. Go ahead, pause the video and factor it, and then when you're done factoring it, go ahead and unpause the video and I'll show you what the answer is. Alright, so now that you've tried to do this, the first thing that I'm going to do to make it a little bit easier is I'm going to find what my greatest common factor is. So I see when I look at all these, they all have an x, and my very last one only has one x. So I know that I have an x in common between them all. Now I'm going to look at my coefficients. So I have a 6, a 3, a 24, and a 12. Well, I notice that all of those have a 3 in them. So I'm going to factor out a 3x. That's my greatest common factor. So I'm going to end up with 2x cubed minus x squared minus 8x plus 4. Now you could do this other ways also. no matter which way you factor, you should end up with the same answer. So if you did it a different way, just hang on and see if you get it right at the end. So now I have my 3x out in front, and then now I'm going to factor by grouping. So I'm going to put the first two together here. 2x cubed minus x squared. My greatest common factor is an x squared. And then what I have left when I group those together is a 2x minus 1. Now I'm going to group my second two terms there. Greatest common factor is going to be a negative 4. So I'm going to end up with a 2x minus 1. Remember, when we factor by grouping, we want two of our terms here to end up the same. So now I'm going to pull that 2x minus 1 out. So I still have my 3x, then I have a 2x minus 1, and then what I have left over is an x squared minus 4. So now I need to see, are all my parts fully factored? Well, I see that I have a difference of squares here, so I need to now factor my difference of squares. So I have a 3x times a 2x minus 1, and then when I factor out x squared minus 4, my difference of squares there becomes an x plus 2 times an x minus 2. And now I'm finally done factoring. So this should be your final project that you ended up with. That should be your final factorization. Now, this shows you that when you factor, sometimes you're not going to use just one method. You may have to use multiple methods in order to factor, and that's okay. You're going to be combining them in order to factor all the way. Do it in whatever order is easiest to you, whichever method is best to you. Just make sure that when you're done, nothing else can still be factored anymore. So now we're going to talk about zeros. So once you know the factors of a polynomial, these factors are their zeros or roots of the polynomial. So I'm going to use the example that we just did, which we just factored. So we have our fully factored form. So that means that each of these factored forms gives us a 0. So this means that we're going to have 4 zeros. Now the way that you find your zeros is you're going to take each of these terms and set them equal to 0 and then solve for x. So I'm going to take 3x, set it equal to 0. To solve for x, I need to divide by 3 on both sides of my equal sign. So I get x equals 0. I'm going to take my next one now, 2x minus 1, set it equal to 0. I gotta first add 1 to both sides, so I have 2x equals 1. Then I'm going to divide by 2 on both sides, and I get x equals 1 half. Now I'm going to take my next term, x plus 2 equals 0. To solve for x there, I need to subtract 2 from both sides, so I'm going to get x equals negative 2. Then I'm going to take my last term, x minus 2 equals 0. Now in order to solve for x, I need to add 2 to both sides. So I'm going to end up with x equals 2. So now my zeros, or roots of my polynomial, are x equals 2, x equals negative 2, x equals 1 half, and x equals 0. That is how you get your roots. Once you have it in factored form, just set each of the factors equal to 0 and solve for x. Last thing that we're going to talk about is end behavior. So if you have an even degree polynomial, both ends are going to go in the same direction. If you have an odd degree polynomial, your ends are going to go in opposite direction, meaning one end will be pointing up, one end will be pointing down. Now in order to figure out which one goes which way for your odd, or which way both ends go for an even function, it's going to depend upon your leading coefficient. So the leading coefficient is the coefficient that's on the highest degree term. So let's say that we have a quadratic. We have ax squared plus bx plus c. That means that my highest term is x squared, so that coefficient in front of x squared is going to tell me which way they point. So since if my a is greater than 0, meaning it's like 1, 2, 3, 4, 5, and it's an even degree function, then that means that both of my ends are going to point upwards. If it's less, if my leading coefficient is less than 0, so it's a negative number, both of my ends are going to put downwards for an even degree function. So how you read this is, as x goes towards negative infinity, so as it keeps moving to the left, f of x is going to go to infinity. As x goes to positive infinity, as it keeps moving to the right, f of x is going to go to positive infinity, meaning it's going to go up. So that's how you read these to know which way they go. So if I had an odd degree function, and I had an a leading coefficient that's greater than 0, so 1, 2, 3, 4, then as x goes to negative infinity, so as I'm going towards the left of the origin, f of x is going to go towards negative infinity. So my left side is going to point down, and then as x goes to positive infinity, f of x goes to positive infinity. So as I move to the right of the origin, my graph is going to point upwards. Okay? And then it's going to be switched around for when your a value is negative, when you're dealing with an odd degree function. Okay? So that is all that I have for you today. To get your points, what you're going to need to do is go to the announcements, click on the link to the Google form, complete the Google form to show me your understanding of the concepts. If you still have any additional questions, please feel free to contact me by phone, email, or send me a message. All of those ways I will be able to respond to you and give you the help that you need in order to succeed in this class.